Hi, I will explain the expected value of the discrete random variable. Let's take a look at an example. The number of television sets per household in a survey of 100 houses in a town gave the following frequency distribution. Okay, this is the frequency distribution, so we can see that in 10 houses there were 0 TV sets, in 75, 1 TV set, in 10 houses, 2 TV sets, and in 5 houses, 3 TV sets. Based on this frequency table, we can find in part A the mean. The mean, so how many TV sets per household on average. To find the mean, I have to add all the TV sets together and divide it by 100, by the number of houses. And then I will know how many TV sets per household on average. Okay, so let's take the first one, 0 TV sets in 10 houses, then add to that in 75 1 TV, that's 75 TVs, then 2 TVs in 10 houses, so that's 20 more, and then in 5 houses, 3 TVs, that's 15 more. And divided by the number of houses, which is 100, and we get 1.1. So the mean is 1.1. Let me erase everything now. That's the mean. And let's try part B. In part B, we should draw up a probability distribution table for the variable x, where x is the number of TVs. So now we would like to prepare a table with probabilities. Okay, I will base it on on the frequency table. The random variable is the number of TV sets in a household, which was picked at random. And based on the frequency table, there is a 10 out of 100 chance of getting 0 TVs in a household, because 10 out of 100 houses had 0 TVs. The next one TV in 75 out of 100 houses, so that's the probability that the house picked at random has 1 TV. Then for 2, it was 10 out of 100, and for 3, 5 out of 100. So that's the probability distribution. So now we're not dealing with frequencies, we're dealing with probabilities. And based on probability distribution, we can find the expected value. The expected value, so the new thing that we wanted to learn today. The expected value is the sum of probability times the value. So I take the probability of getting a value and I multiply it by the value for all the values. So let's try. So now I have to base it on the probability distribution. I take the first one and I can see that in 10 out of 100, that's the chance of getting 0 TVs. Plus, it's a sum. In 75 of 100, I would expect 1 TV, plus the next one. In 10 out of 100, I would expect 2 TVs, plus the last one. In 5 out of 100, I would expect 3 TVs. And the result is 1.1. So the expected value is 1.1. Okay, the expected value is the sum of the product's probability times the value. So the calculations for expected value and mean are similar, and the result is the same. The expected value is actually sometimes called the mean of a random variable, and it is just a prediction, what we would expect the average value to be. So when we calculated the mean It was practical. I had a frequency table, and based on my data, based on my results, I could find the mean result. Expected value is theoretical, hypothetical. I have the probabilities, so I expect my mean to be 1.1. It's modeling. The way I understand it is that if you throw a die, a fair die with the probabilities of getting a 1, 2, 3, 4, 5, 6, 1, 6, 1, 6, 1, 6, 1, 6. Obviously, if you throw the die once, six times, you don't have to get the results 1, 2, 3, 4, 5, 6. You can get 2, 2, 2, 3, 4, 5. You just throw the die 6 times. So the average result, if you just throw the die 6 times, doesn't have to be the average of 1, 2, 3, 4, 5, 6 or 3.5. But the expected value is 3.5 because if you throw the die a lot of times, almost infinitely many times, based on the probability, you expect to get the same number of ones, twos, threes, fours, fives, and sixes. So you expect your average result to be 3.5. And that's what the expected value is, just the expectation of the mean. And we have to remember from this topic that to find the expected value, we have to use this formula. The expected value of the random variable x is the sum of probability times the value for all our values. That's the formula for the expected value.